Hello world! Today we have a new topic, full text search, or just text search. And this is when you have some text information in your database and want to search inside this text. So, when you have some fields that are text and are longer than few characters or longer than few bytes, uh, sometime, sometimes user wants to search and retrieve some documents from your tables from your database. But text search is just a part of a bigger science called information retrieval. And information retrieval is not just a science; it's a big market, and now it's already important part of human knowledge and human experience. And I highly recommend you to read some books or take some courses separately on information retrieval. I will put some recommendation below the video. So, information retrieval is a science, and now we will discuss some fundamental problems and goals and features of information retrieval. First of all, information retrieval is about satisfying information need. So you have some documents and user have some information need. He or she wants to find something, some documents from your collection. And to measure efficiency of your information search, you usually use special thing called relevance. And document is relevant if it's what a user wanted to find in a collection. And we have two fundamental relevance measures. First is precision, is number of relevant documents divided by the number of retrieved documents. And the second measure is recall. So it is a ratio of relevant of retrieved retrieved relevant documents among all relevant documents. And we can easily make our search precise without recall by showing nothing. Or we can make our search recall efficient by showing to user everything. But we want to have some balance among precision and recall, and both of them are numeric measures based on relevance according to user, and user is human. So this science is fundamentally based on not very strict relevance definition. One of the useful and most cited models of information retrieval is so-called model of bag of words. Bag of words means that you interpret your document like a set, an ordered set of normalized words. Words that are converted to its normal form, and you do not order these words. And usually query of a user, text search query of a user also can be represented by a bag of words. This model is useful because it makes search simple, but it is not always the best model for research. For example, take search green apples. So you want to find documents which contain word green. You want to find documents which contain apple. And then you intersect both sets and return user everything that contains something green and something about apple. But it's not necessary that all documents are actually relevant, even somewhat relevant, because there may be actually text about green walls and red apples and nothing about green apples in the document. One important concept here that we were talking is normalization of words. This is not always making some word against other word. For example, here we have algorithm so-called soundex. This algorithm normalizes how the surname sounds. This algorithm was designed to search in textbooks, in phone books, by the surname of different people. So surnames which are inscribed differently, which have different text form but sound similarly, are converted to the same hash code, and you can search not just by how the surname is written, but how the surname sounds. This is because the algorithm is called soundex. In text search, we usually don't bother by how the word sounds, but we want to remove plurals, we want to remove some endings and some other features of the word. There are two main concepts of word normalization. First is stemming, when you just cut the endings and the prefixes of the words which are irrelevant. And the second way of normalization is lemmatization or morphological analysis. And this is when you dive deep in a specific language and try to analyze what are the parts of morphological parts of the word and which are relevant and which are not relevant. One of the problems of information retrieval, of text information retrieval, is the homonyms. This is when different semantically words have same written form or maybe same sounding form. Here we have jaguars. We have three semantically different jaguars. First of all, it's big cat, and it also may be a drink, and it also may be a car. And which one is a jaguar users search for, we must deduce from a context, maybe from our knowledge about user, or maybe from other parts of the query. And finally, fundamental problem of information retrieval is relevance ordering. So we want to show user most relevant documents because we can have a billion scale collection of documents. Like collection of all web pages on the internet is huge. There are millions of pages which mention green and apples. We can show the user maybe 10 results, maybe we can show him 10 pages of results, but we have no chance of showing everything to user. Simplest way to order documents according to relevance is TF-IDF measure. TF stands for term frequency, and this is a count of words that match our query and are contained within the document. And IDF is inverse document frequency, is how rare is a word in a search query, how descriptive, how deterministic is it, how selective among the set of our documents this word is. So we calculated this as 1 divided by frequency of documents, count of documents that contain specific word. For example, in green apples, green is much more common word than apples because there are much more documents that contain green than count of documents that contains apples. So IDF of green is smaller and impact of green to the relevancy of pair document and text search query is smaller than impact of apples. But both of these, TF and IDF, we can calculate in different forms by the different equations. Here are tables taken from Wikipedia, which lists 5 ways to calculate TF and 5 ways to calculate IDF. And we have already 25 ways to calculate relevance for a document in a set. So TF-IDF is quite simple way to create relevance ordering, and it's discussed actively in scientific papers. But it's probably not most efficient. But usually we don't need the best relevance metric. Best relevant metrics used by big search giants like Yandex or Bing or Google or Baidu. Usually these relevance metrics are commercial secret of companies, and scientifically available relevance metric are just much more simpler forms. But for small collection of documents, we need just some easy way to calculate relevancy. And now let's discuss what we have in Postgres for text search.